Welcome to the first unit. These are the contents. Let us first discuss about an image. An image is the graphical. Images play an important part in multimedia. Images can be generally divided into two formats. For example, as shown, these are the types of images. A binary image. In case of color images, it is represented. Let us discuss what is digital image processing. These are the fundamental steps in image processing. These are the components of image processing system. Let us understand what is a pixel. Let us see what is the image. Let us understand what is a pixel pitch. This is how we can denote the. In case of this is the coordinate conventions. Let us understand basic relationships between the pixels. Relationships describe how pixels relate to their neighbors. There are different types of relationships as neighborhood, adjacency, connectivity, and distance. In case of neighborhood pixels, there are two categories, 4 neighbors and 8 neighbors. In case of 4 neighbors, we look for upside, downside, left, and right. In case of 8 neighbors, we include the diagonals as well. In case of adjacency relationship, pixels are adjacent if they share an edge or a corner. In case of connectivity, the path of the adjacent pixels defines the relationship between the pixels. Another relationship given by distance measures is Euclidean distance, city block distance measure between the two pixels. So here as an example, we can consider to find the connected regions of the image that you want to analyze for adjacency or connectivity. A real-time example, flood fill algorithms or a flood fill tool in a paint programs that uses the connectivity to fill the regions. This is the in general basic relationship how it looks like when an image is represented with the help of XY coordinate system. Then for a pixel located at XY, these are the other pixels that we can consider to have a relationship with, which will be represented by x minus 1 comma y minus 1, x comma y minus 1, x plus 1 comma y minus 1, and so on. So this is considered as the conventional indexing method. Let us understand what are the 4 neighbors of a pixel. A pixel P at coordinate x, y has 4 horizontal and vertical neighbors whose coordinates are given by x plus 1, y, x minus 1, y, x, y plus 1, x, y minus 1. So this set of pixels are called as the 4 neighbors of P, denoted by N4 of P. Each pixel is a unit distance from pixel x, y, and some of the neighbors of P, they lie outside the digital image if x, y is on the border of the image. So neighborhood relation is used to tell what are the adjacent pixels for any pixel. These are useful for analyzing various regions of the image. For neighborhood relation considers only vertical and horizontal neighbors. So these pixels only represent 4 neighbors of a P. Now let us see the 4 diagonal neighbors of P. They have the coordinates x plus 1, y plus 1, x plus 1, y minus 1, x minus 1 comma y plus 1, x minus 1 comma y minus 1, and these 4 pixels are given by nd of p. So the diagonal neighbors of p denoted with nd of p, and these are the 4 pixels. Diagonal neighborhood relation, they considers only the diagonal neighbors for the given pixel p. Let us understand what are 8 neighbors. The 4 diagonal neighbors together with 4 neighbors are called as 8 diagonal neighbors of P, denoted with N8 of P. So it will consider horizontal neighbors, vertical neighbors as well as diagonal neighbors, denoted with N8 of P. So 8 neighborhood relation considers all neighbor pixels. Let us understand what do you mean by connectivity or adjacency. Two pixels that are neighbors and have the same gray level are called as adjacent pixels. So here is a 4 adjacency and 8 adjacency representation. Let us understand for a given binary image the 4 adjacency relation between the pixels. For example, I am given a set v is equals to 1. So I need to find its adjacency or connectivity with other pixels. Those are having the value 1 only. So this one can be connected with this one with 4 adjacency, that is the diagonal adjacency. Then this one can be connected with this pixel which is having a value 1 with 4 adjacency, and this one can be connected with this pixel with a 4 adjacency, because these are the just a unit distance from each other. Then this pixel can be connected with this one, and then this pixel, I cannot connect this pixel with this one directly, but I can connect this pixel with this, then this pixel with this. Then it will form the 8 adjacency, because this is 4 adjacency and this is 4 adjacency. So the total will be 8 adjacency. In case of a grayscale image, let us say I am given the uh, pixel values of vertex set as v is equals to 1 comma 2 comma 3 comma 10. Then for these set values only I need to look the adjacency. So I don't have a pixel with value 1, so I won't consider. I have a 2, so I will consider it. This 2 is connected with which pixels. So this 2 is connected with this 10, then this 2 is connected with this 8, using these are like the diagonal connections. Then this 2 is connected with this 3. This is the vertical connection. So then I can consider this 10 is connected with this 8 with 8 adjacency, because this 10 is connected to 2 and this 2 is connected with 2 8. So this is 4 adjacency plus 4 adjacency. So the total 8 adjacency. Then if I consider this 7, this 2 is not at all connected with 7 and it is not adjacent. Hence, there is no connectivity between 2 and 7. Similarly, for 2 and 70, these are also not adjacent pixels, so they are not connected. Let us understand what is M adjacency, that is mixed adjacency. If there are multiple ways to connect the elements, that is many paths are available, so there is an ambiguity between the paths, then the mixed adjacency rule comes into picture. So this rule says that if elements can be connected by both 4 adjacency as well as 8 adjacency, then give the priority to 4 adjacency first and then form the connections. For example, for the given pixel representations of 0 1 1 0 1 0 0 0 1, so here this one can be connected with this one with 4 adjacency. Then this one can also be connected with this one with 8 adjacency, because this is a diagonal. So first give a priority to 4 adjacency. Connect this one with 4 adjacency. Then this one connect with this one with 4 adjacency. Then connect this one with 4 adjacency. So here this is called as the M adjacency. The last connection, that is 1 to 1, this is actually 8 adjacency and not 4, because this is the diagonal pixel.